don't know if you guys can hear that. It's a theme song from like one of the greatest Nintendo games of all time. Well, Mike Tyson Punch Out, folks. It has significance in today's lesson. Ready, fight. All right, we're going to rock some fractions again today, but today is the day you are going to learn how to simplify fractions, or at least be introduced to it, okay? So first, let's talk about fractions. What are fractions? Well, here's a whole bunch of fractions right here. Fractions are supposed to represent an amount. What kind of an amount? That's right. You might have just said it. It's supposed to represent something that's more than nothing, but less than a whole, right? Or you have fractions that are bigger than one whole, which are mixed numbers, but there's still a fractional amount usually there because you could pull the wholes out. But fractions are meant to represent something that's more than not there, but it doesn't fit in our normal number system. Here's a whole bunch of examples of, get it, whole bunch. There's a whole bunch of examples of fractions right here. And whatever the denominator is, they're all equating to one whole. See how one whole is the same thing as 2/2, which is the same thing as 3/3, which is the same thing as 4/4, and 5/5, and 6/6, and 8/8. Why no love for sevenths? I don't know. I didn't make this graph. Ninths isn't there, so tenths, twelfths. The reason for this, ladies and gentlemen, is because simply you could have fractions that are worth the exact same as other fractions, right? You just might have to have more of them. For example, let's look at eighths. See eighths? Right here to right here is the exact same amount as from right here to right here. So that's 1/2. How many eighths is the exact same thing as 1/2? 1, 2, 3, 4. 4/8. So that is called an equivalent fraction, right? So let's look at a couple equivalent fractions. Let's say, for instance, I call and I say, hello, I'd like to have a pizza today. And the pizza guy is like, sure. And he eats some of it. And this is what I get. Okay. Is this the same amount as this? Yes, but there's two pieces here and there's only one piece here. Oh, that's right, because this one's cut into smaller pieces, so I get 2 of them. This one's cut into a huge piece, I only get 1, but they're still the same amount, because 1/2 equals 2/4. And it also equals 4/8, right? This is still the exact same amount of pizza as that is, and as that is as well. That is a group of equivalent fractions. Are there more equal fractions to 1/2? Yeah, how many more? A lot more. Let's look at some examples of fractions that are worth the exact same amount as 1/2. Well, remember, to make an equal fraction, you have to multiply the top number and the bottom number by just the same number. So if I have 1/2 here, if I multiply 1 times 2 is 2, 2 times 2 is 4. I multiplied both the top and the bottom by the same number, got 2/4, and so that's equal to 1/2. As we notice back here in the picture, 2/4 is the same as 1/2. So the rule is to find an equal fraction, you just have to multiply the numerator and the denominator by the same number, whatever that number is. Okay, so here's a whole bunch of examples of 1/2. If I multiply them both by 4, it's 4/8. If I multiply them both by 5, it's 5/10. Now, if I multiply them both by 6, right? 1 times 6 is 6. 2 times 6 is 12. It's 6/12. This is a chain of equivalent fractions. Now, how large could that go? How far this way could we continue to find equal fractions? Well, that answer is infinite, because as long as this number is the same as this number that we're multiplying the original fraction by, you're going to create an equivalent fraction. Now, so then the real question is, what's the biggest number I could put here? Infinity. Infinity, because the infinity is the idea that the numbers never stop, right? So I can continue to put larger and larger and larger numbers here, and I can keep going find another equal fraction, another. The only thing that's in common is the numbers themselves are going to get larger, but the amount will be the same. So that's what an equivalent fraction is. Is it complicated? Sure it is, but it's as simple as pizza, right? It's not, it doesn't have to be complicated. The idea is you can keep breaking these into smaller pieces and smaller pieces and smaller pieces. And when you do, you're going to get more pieces and more pieces and more pieces because if you're going to get smaller pieces, you need more to represent that same old amount. Now, is half the only fraction that has equivalent fractions? No, all fractions have equivalent fractions because whatever the original fraction is, you multiply the top and the bottom by the same number, any number in the world, you're going to create an equal fraction. Now, here's the issue. We've always gone this way and have made our old fractions larger. We do this when we add and subtract fractions, right? If we're adding 1/2 and 2/4, we have to turn a half into fourths, and we find its equal fraction with bigger numbers. We've gone right in this table. We've gone right with fractions all year, but we've never gone left. We've never taken a 6/12 and said, what is the smallest numbered equal fraction to 6/12? Because numbers go infinitely to the right and get bigger, but fractions only have one that has the smallest number. Right? You can't go smaller than 1/2 here. Every fraction has one smallest equal fraction. Okay? It's called its simplest form. Today we're going to learn that we have to find that simplest form. Now, so if I had 15/30, we know that 15/30 is equal to 1/2, but how would we find that? That's where the music comes in. Bop, bop, bop. We are going to find equivalent fractions with boxing. Oh, that's fun, right? So 15/30 is equal to 1/2. How do we find that? Boxing. I'll explain. So the way I've always taught my students how to break a fraction down to make it smaller yet equal, there's two ways. You can figure out that 15/30 is 1/2 by giving it one humongous punch, or you could do a little jab, 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 jab. There's two options. Usually my students like the jab, 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 jab better. However, I teach both, okay? So first, here's the perfect punch. Bop! Down. One punch. Just one. It's like that super move. It takes a little more work to get that super move, though. Or you could work on the jab, jab, jab. He's counting. Jab, 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 jab. Pow! Both of them get the same result. The boxer on the ground is the simplest form. You get the analogy here? So I'm going to teach you how to get the perfect punch to make the fraction simplest, or you can use the jab, jab, jab method, and that too will take your bigger numbered fraction and find its smallest equivalent form. First, I will show you the perfect punch. Now, if I show you the perfect punch, here are the rules. They have those nasty math vocabulary terms. The first rule for the perfect punch is you have to find the greatest common factor. Oh, sorry, I just gagged a little bit because that is such a disgusting math term. Find the GCF, the greatest common factor, and then you just divide both the top and the bottom by that GCF. So first, we got to figure out what in the world a GCF is, right? Sounds like something that an electrician would use. So a GCF is the greatest common factor. So what's a factor? So what I normally do when we're in class is I say, everyone, think about your age. I'd like for you to think of all the factors that your age has. So I'll say 32. I will look at 32, and I'm going to look at 32's factors. This is what a factor is. Numbers that you can count by to get a number. So I'm 32, and I'd say, can I count by 1 to get 32? Sure I can. Now, every number that you can count by is paired with the other one. How many ones make 32? 32. So the first two factors that I could think of that's 32 is the smallest one is 1 because I can count by ones to hit 32. The biggest one's 32 because I can count by 32s to hit 32, right? And they're pairs because it takes 132 to get to 32 or it takes 32 ones to get to 32. Now, the reason I start with the smallest and the largest because it's like a sandwich, right? All the other factors will be somewhere inside of this. There's not going to be a number you can count by to get 32 that's bigger than 32. And there's not going to be a number smaller than 1. Every number has 1 and itself as factors. So 2, is this even? Sure it is. So how many 2s make 32? 16. So those are my next 2 in the sandwich. That looks like a good sandwich. What about 3? No, because 3 times 10 is 30. 3 times 11 is 33. What about 4? Oh, yeah, I can count by 4s. How many 4s make 32? 8. 8. See, now the sandwich is coming in, right? We're at 8 and 4. There's only a couple other options. What about 5? No, we know you can't count by 5s and hit 32 perfect. 6? Ooh, 6 times 5 is 30. 6 times 6 is 36. So, ladies and gentlemen, that's it. Those are all the factors. So what you do to get the biggest punch is you find the factors of both numbers, okay? So if I had 32 is only one number, but to find the one punch knockout, you look at your fraction, you look at both numbers, and you find the biggest factor they both have in common. So like, here are a list of factors for 1 through 10, right? So if we were trying to find the biggest factor that 8 and 4 have, what is it? Well, 4. See? So everyone has 1 in common. And then you when you're simplifying with one punch, you just find the biggest factor that both have in common. So let's look at 15 and 30. First, we got to find all the factors of 15. 1 and 15, 2, no, 3 and 5. 1, 3, 5, and 15. Those are the only factors that 15 has. So we're going to do the perfect punch. What about 30? 1, 30, 2, 15, 3, 10, 5, and 6. There we go. So what's the biggest factor they both have in common? 15. See it? So that's my big punch right there. So what fraction could I put on the left that would use the magic number of 15 to get 15/30ths? Well, 1 has to be on the top and 2 has to be on the bottom, right? So that's your perfect punch. We went right from 15/30ths to 1/2. Perfect punch has a lot of work behind it, though. That's the only problem. That's your answer. Well, Mr. Shaw, you said there's a different option? Yeah, the jab, jab, jab. See, it still does the job. Look at him. He's down there spitting stuff out and falling down sideways and stuff. It's called the jab, jab, jab. Let me show you the jab, jab, jab. Beautiful thing about the jab, jab, jab is you can figure out any number that they both have in common and use it. And then look at that new number. Does it need another jab? If it has another one in common, you jab it again. If it has another one in common, you jab it again until you can't jab it anymore, and then it's in its simplest form. Now, the cool thing about this is they both get the right answer. They'll both get that same answer because 15/30ths is never simplified until it hits 1/2. You'll always be able to jab it with something until it goes down to 1/2, just like every fraction. So I'll get 15 and 30. Oh, I know that I can count by 5s for both of them, right? 15 and 30, you just look at it. You're like, oh, 5s. So cut that. The top one would get cut down to 3 because it takes 3 5s. And the bottom one would get cut down to 6. 6 because it takes 6 5s. Is there another jab that you see? Oh, yeah. 3 and 6 for sure. They both have 3. How many 3s make 3? 1. How many 3s make 6? 2. Oh, check that out. It is now defeated. Got him. Let's start today's work, shall we? We're on number 1 on page 95. 2/3 times 30. 2/3 times 30. Remember, the first thing that we have to do is put a 1 under it. Now, this is what's cool. We could multiply over and get 60 30ths or 60 thirds. And now we have kind of a nasty number to cut down. And that answer is 20, right? How many threes go into 60, 20? But watch, there's a different way I could do this. What if instead I have 2/3 times 30 over 1, and before I multiply across, I simplify. Now, here's the thing about simplifying. You can simplify just 2/3. Well, you cannot simplify 2/3. That is already in its simplest form. You can simplify 30 over 1. Not really, not without turning it into a whole number. But the rule when you simplify before you multiply is you can simplify any top to any bottom. So what about 2 and 1? No. But what about 30 and 3? Oh, yeah, they both have 3, right? How many 3s make 3? 1. How many 3s make 30? 10. So that cuts it down and makes it simpler, right? That, no, we already said, no, we can't simplify that. But, yeah, we can't simplify that, but we can simplify 30 and 3 by cutting them both down by 3s, right? The top one would turn into a 10, and the bottom one would turn into a 1. See how we did that? They both have 3s in them. 10 and 1. And now, if this makes 0 sense to you, hopefully as we continue to work on it, it'll make more and more sense. However, guys, it doesn't matter if it doesn't make sense to you. You can always just multiply across and simplify that way. This is just something to put in your math belt, right? This is a nice, beautiful trick that if you give it a little bit of patience and time, you'll get eventually. This first time, I'll probably have like 10 students in all of 5th grade that are like, oh my gosh, I get it. And then as we move on, little by little, every day, one new person will get it until you guys will all get it. 2 times 10 is 20. 1 times 1 is 1. 20 over 1 is 20. They both get the same answer. This is just a different route to get there. Okay, today's homework. First thing we're going to do is 2 over 3 times 30 over 1. Well, we already did that. Okay, let's do the next one. First thing that we want to do, so we're going to go down again, right? For number 3, 5, 6 times 4 over 1. You got to put a 1 under it, turn it into a fraction. And then you can multiply across and get 20 over 6. Or we can simplify first. Can you simplify 5 over 6? No. 4 over 1? No. 5 over 1? No. 4 over 6? Yeah, they're both even. Whenever they're even, cut them in half. So 4 turns into a 2, and 6 turns into a 3. Now we multiply across, we get 10 thirds, and then 10 thirds turns into 3, 6, 9, 3 and 1/3. So that answer is 3 and 1/3. What about 7 over 20 times 5 over 14? Well, let's reduce first. Now, let me just prove something to you real quick. If you did not reduce first here, you would have gotten 20, dare I? You would have gotten 20 over 6, right? Because you just multiply across. Now, this answer too, we would have gone 6, 12, 18, and 18 still had 2 left over, 2, 6. But now that you're big boys and big girls, everything has to be simplified. So 2 over 6, each of those can be jabbed, cut in half, cut in half. So times 2, what times 2? 1. What times 2? 3. So this way you still get 3 and 1/3, right? I just am proving to you that you can choose any of these routes and they're all going to get to the same answer, okay? They'll all get to the same answer. All right. 5. This one, they both have 5 in them. So that turns into a 1, that turns into a 4. 7 times 1 is 7, and 4 times 14. But wait, Mr. Stahl, hold up. After you reduce that, are you allowed to reduce again? Yes, you can. But Mr. Stahl gets 7 and 14. Aren't they both something that you can count by 7s? Well, yes, they are. That would turn into 1 because it takes 1 7, and that would turn into 2 because it takes 2 7s. Now multiply across, and you get 1/8. And that's simple, right? Or you could have multiplied 7 times 5 and got 35, and 20 times 14 and got 280. and had to take down 35 over 280, which is gross, folks. This way is much easier. Simplify before multiply. That is the answer. All right, what about down here? 6, so 9 and 10? No. Here's a trick. Whenever they're 1 away from each other, it's impossible to simplify them. So you cannot reduce this. Can you reduce these? No, you can't. 7 and 10, there's nothing that goes into both of them except for 1, and that doesn't reduce it. 9 and 10, 7 and 10. Therefore, there's no way to cut this one down first. So you multiply across, and you get 63 over 100, and guess what? It's simplified. There's no smaller equal fraction than 63 over 100. What about number 9? Well, look at 5 and 25. Look at 6 and 24. You could totally reduce those. 5, so 5 would turn into a 1 because you can count by 5s. 25 would turn into a 5 because you count by 5s. And then what about 6? Well, there's a couple things you could do. You could look at it right away and be like, oh my gosh, I can count by 6s. You might not know that. You might be like, I didn't know 24 you can count by 6s to hit. They're both even. Cut them in half. You could turn that into a 3, the other one into a 12. Whenever they're both even, you're always allowed to just cut them in half. But here, I know that I can count by 6s, so I would say 1 and I'd say 4. If you cut them in half, you're still going to get the right answer because you'll just have to simplify after you get your answer. 1 times 1 is 1, and 4 times 5 is 20. What about 8 over 49 and 7 over 10? Is there anything I can cut those down by first? 8 and 49? No. 7 and 10? No. 8 and 10, they're both even. Cut them in half. Turn that into a, turn that into a 4. Turn that into a 5. What about 7 and 4? Oh, I got my 7s. 1 of those, 7 of those. And up here I said 4. And down here I said 5. Multiply across, I get 4 over 35. What is up? Okay? All right. Turkey. When I'm asking if you guys watch the video, you're going to say, Mr. Stahl, you had a goofy turkey. And I'll say, I had a goofy turkey. And if you didn't watch it, you're just going to think it's a weird looking turkey. But if you watch this, you're going to know it's a goofy turkey. All right. Which fraction is not the same as the others? Well, 3 over 9 is 1/3. I know that. So those are good. Those are good. So everything's going to have to be equal to 3/9 or 1/3. Is this equal to 1/3? Well, 1 times 8 is 8. What's 8 times 3? 24. Oh, yeah, so that's equal. Yeah, that's equal. 10/30 is definitely equal because times 10 times 10. From here to here is times 6 times 6. That's equal. Times 9 times 9, that is not equal. Okay, if this is times 9, this has to be times 9, but which would be 27, not 36. And then 20, yep, that's equal. So your answer there is 9 over 36. All right. In the Fireside Ski Shop, 11/28 have tassels. Of those, 7/11 are blue. What fraction are blue with tassels? What fraction are blue with tassels? So 11/28. And we're going to multiply that by 7/11. Check that out. Remember, you just have to take a top and a bottom. They're both 11. I can count by 11s. How many 11s make 11? 1. How many 11s make 11? 1. What about 7 and 28? Oh, yeah, I can count by 7s. How many 7s? 1. How many 7s? 4. Now multiply across. 1 times 1 is 1. 4 times 1 is 4. Boom. That answer is 1/4. So in Fireside Ski Shop, 11/28 have tassels. Of those, 7/11 are blue. What fraction are blue with tassels? 1/4. 1/4. In the shop, 27 of 32 have zippers. Of those with zippers, 8/9 have hoods. What fractions have hoods and zippers? 27 over 32. 7/11. No, what? 8/9. Can I simplify? No. Can I simplify? Yes. No, absolutely not. Can I simplify these? Yeah, again, another sideways one. I can count by 9s right? How many 9s make 27? Let me use a different. The hardest part every year is having students just make this so you can see it. So how many 9s make 27? 3 of them. I can't use that color. 3 of them. How many 9s make 9? 1 of them. How many 8s make 32? I don't know if 8s go into 32? Oh yeah, 4 of them. So I can do that. Let's pretend I didn't know 8 can go into 32. I know they're even, so I can cut them in half. 4, 16. Can I, oh, they're even again. I cut them in half again. 2, 8. Oh my gosh, they're even. I can cut them in half again. 1, 4. So these are my numbers I have left over after I pop, pop, pop. So 3 times 1 is 3. 4 times 1 is 4. So that answer is 3/4. Looks like we got a lot of glare. I'll have to work on that. So 3/4. 5 of the 16 workers know how to ski. 1/5 of those know how to snowboard. So we're going to find 1/5 of 16. No, 1/5 of 5/16. 1/5 of 5/16. Does that glare better? A little bit when I go like this. So is there anywhere I could reduce first? No. 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 Yes, sir, Babaruski. I can count by 5s. How many 5s make 5? 1. How many 5s make 5? 1. So 1 times 1 is 1. 1 times 16 is 16. That answer is 1/16. Now, if you are right now saying, I just don't get this, that's very common. We're going to have to put some time into this, but you will get it. I know I say that a lot, but you will get it for real. Don't give up. Show up to all of our classes, and you'll get it. Okay? All right. Puzzle Penguin. You know what? Not today, Puzzle. Not today. So your guys' HW is, we did not do 2 through 12 evens. So do 2 through 12. You know what? We'll work on 2 through 12 even on Zoom. All right. Thanks for watching. And like I said, it's understandable that this is a little bit frustrating. It will get better.